So welcome to our ICCSW Keynote talk. We are really excited to have one of the champions of open source here with us. He's the Director of Open Source and Science Outreach at Google, where his team works in supporting open source through releasing of open source software and also holding programs such as Summer of Code for students who also get involved with open source software and contribute to that community. So I just give you Chris DiBona. Please welcome him.
Thank you so much.
Thank you.
So when I saw the program for the ICCSW Colloquia conference, I saw a lot of machine learning stuff. So we released something called Deep Dream a number of weeks ago. And I'll talk about that very briefly. This talk is not about machine learning. I apologize for that. But we did release this stuff. And this is the snail eyes-ification of Google. And I'll explain what that means later. But it's kind of creepy and weird. But yeah, I wanted to show that. And that's the old logo, because I know we changed our logo recently. But I adore all of you, but I didn't want to change the logo. So Google and open source. Let's keep going. So who am I? Other than completely incompetent at PowerPoint, as you can see by the color of the bullet points. I look after a variety of sort of open source and open source related things at the company, including a lot of our policies around patent standards and API availability and construction and specifications. I assure you this talk is not going to be about open source licensing the whole time by any measure, although if that's what you want, I can talk about the GPL until we all die of old age. Yeah, so this is my past. So I like to start by actually talking about where open source came from in the first place, and how the internet and open source were sort of inexorably entwined in my mind, and that's enough for me. And you asked me to speak, so that's what you get. So I would ask you very, very simply, why did the internet take off with the advent of the web and everything? And I actually don't need an answer, because I'm going to tell you the answer. It was a rhetorical question. Ooh, that's very exciting. How you doing? So in the early 90s, you might remember, actually not the 90s, but in the early 90s, if you looked at the desktop operating systems, it was not a great scene, okay? You had largely a Windows monopoly on something like 90% of the desktops, and then the remainder were probably older versions of Windows and then some Macintosh. And if you had a successful desktop program, you were often given a choice by the powers that be in these various companies. You could sell to them. It's getting even more exciting, lighting wise. Can you even see me? I don't know. You can see my slides, and that's really what's important. I know my slides are terrible. But the thing is, if you tried to have a popular program, and it wasn't just something like a game or whatever, you would be given a choice. You can, sell to Microsoft or sell to one of the big providers, or they would create something to compete with you or make it very difficult for you to ship. And this went on for years. This was a... Dang, I now have to wear a shirt. So this went on for years. And then the web came out, and everyone was like, wow, why is everyone using the web so fast? It's amazing. Well, first of all, you could always just view source and then make your own web page very, very quickly. But also, you could put that web page on the internet almost immediately using free software and using open source software. And so you had a lot of universities who were sort of at the forefront. They were the thin end of this particular spear. And they were doing things like they were downloading Apache and other sort of proto web servers. And then they had these really weak, at the time, web browsers like NCSA Mosaic and then Netscape to view the content web. And they didn't have to ask anyone's permission. They didn't have to buy a client license and the rest. And meanwhile, big companies, they were going to the other big companies like Microsoft and Oracle and Sun and the rest saying, we really want to do this internet thing, woo, And they'd be like, well, we're going to have one of our technical account managers contact you back in about a week. And they're like, but we want to put stuff on the web now. And they're like, we'll get to you. And then they would get to them and they'd say, okay, how many people do you think are going to be using your website? And they're like, I don't know, a bunch. And they'd be like, well, we're going to need to have you get a client license for each one of them. And they're like, what? No, that's crazy. We want a really popular website, and you're incentivizing us to not have people go to our website because we'll have to pay $1 per person per year. And so they tried to sell these client access licenses. That's what CAL meant. And so people wouldn't buy Internet Information Server. They wouldn't buy some of these like Sun 1 servers because they would often come at a very, very high cost. And it was really complicated to buy them, right? And then, meanwhile, some nerd in their IT department's like, I downloaded Apache, just stick it in this directory and you'll be fine. And so basically none of these commercial providers were keeping up. All the open source people were like, yeah, we can do that, no problem. And they were able to ship very, very quickly without asking permission, without getting a license, without having to, figure out what their select agreement was with Microsoft. And a lot of these words don't mean anything anymore because, in fact, they were just such a drag to revenue that, a drag to getting things onto the internet, they just faded away. So you have this world of open source that is rushing to serve this demand on the internet, right? And so you saw the rise of Linux and BSD at the same time as the internet was growing. And in fact, you saw that the rise of BSD was actually more popular than Linux for a very long time until multiprocessor CPUs, multi-core CPUs and multiprocessor motherboards were becoming cheaper and more popular because BSD didn't really catch up with that until actually more recently. So Linux just was having that hockey stick of adoption. And everyone was like going, well, what is open source, And that's sort of where open source came from. And it's where the internet came from, and it's where Google came from, right? So on an internet like this, anyone can put up a website, anyone can go and view that website, and that's sort of where Google came from, right? So if you looked at how people put information online, overwhelmingly these open source solutions were winning or had won. Or there was such a great competitive landscape between commercial and open source implementations that everyone was still competing to serve their users, their developers, their web developers better. And that's sort of where we came out of. And one of the things I say in this slide that I don't know if you care to hear from me, but whenever we would see standards being proposed, whether they were latter-day HTML standards like Xforms and the rest, what really, really mattered was not that a W3C, which is a fine, august organization, would say that this is something we want to do. It was nice that they did that. But if there was an open source implementation that people actually used, then they would actually become popular and useful and standardized. And vice versa. If somebody came up with something they really wanted to have done in a standard way, and there was no open source implementation, it would often not see much in the way of popularity. And this was actually brought into very stark light with Xforms and HTML5. A lot of people wanted Xforms to be the next version of HTML after HTML4, but it never really took off. And HTML5, which really came out of a documentation project of what all the browsers were doing, it ended up being sort of the chosen standard. So there you go. The thing about open source you have to realize is that over time, so at Google, we crawled the internet for search and stuff. I know this is big news. And so what we did a couple years ago is we said, okay, find me every open source, every software, every piece of source code that is under an open source license. Or if there's an open source license in the directory with it, find it for me. So we crawled CVS, Subversion, not CVS, but Subversion, Git, and Mercurial repositories all over the web. And as well as found, files that were just being hosted as content type at, HTML. And we found, after we deduplicated them, and this was some time ago, about 30 million files under open source licenses. And it was about half and half permissive and non-permissive licenses. And so what this means is if you're writing software, you can bring to bear the force of, I want to say, 20,000 developers working for 10 years. And that can be your starting point. And this is a really important thing to learn. And in fact, this is older now. I'd say it's probably another 2 million files are probably out there that are licensed under open source licenses now. And so as a company like Google, I'd like to think we're not stupid, right? So we don't start from scratch. We don't write our own operating systems. I mean, I know what you're thinking about Android right now. But we don't start with our own kernels. We use Linux. We don't start with our own languages. We use, at the time, GCC and then now LLVM and Clang. And we don't start from scratch. We stand on the shoulders of computer science giants all over the world, right? So, that's an important thing about it. And then you might say, well, wait a second, that's a lot of code. Isn't code super valuable and stuff? Why are they releasing all this? So a lot of people had their ideas and their theories about why people release open source code. And so instead of, we had people postulating that it was a cargo cult, like in The Gods Must Be Crazy, or it was gift economy. They came up with all these like pseudo-intellectual reasons why people did open source software release. And instead of that, a fellow by the name of Kareem Lakhani, who's now over at Harvard Business School, and he was at the Sloan School at MIT, he came to me and my friend Jeff Bates, and he said, why don't we just ask them? It's like, wow, that's really innovative thinking, Kareem. And so we asked them, we're like, we came up with a whole bunch of reasons, and we said, just mark off the ones that you identify with, which is why they don't equal 100, in case you're wondering. It's actually, this is like the computer science optimist slide. This is a great slide, because when you ask why people release all this incredibly valuable software, why do they do it? They're like, well, I was curious. I wanted to become smarter as a developer, as a programmer, as an engineer. I needed it at work. I didn't want to wake up in the middle of the night, so I'm just going to use open source whenever I can. And a full third of them, they identified with the idea that these open source licenses articulate a moral stance, right? That it's something that they believe in, that they should be sharing knowledge with their colleagues. And only 10% of them hate Microsoft or Google or whoever, right? 11% of them, right? So that's really great, because I've been in open source, starting about 1994, and about half of my interviews when I was working at VA Linux and at Slashdot, they always started like, you guys, you just hate Microsoft, right? And it's like, I know that this plays well, X versus Y, but it's not really what drove me ever. And it was really nice to see that 90% of my colleagues were like that too, and only 10% were haters. So this was a really great outcome to learn there. I have to apologize. I try to get rid of all the animations in these slides. I hate animations so much. So as Google started, what we would do is our venerated founders. Now, our founders went through their building at Stanford. They found every computer that wasn't plugged in. They took it to their lab. They plugged it in. They loaded Linux on it if it wasn't already loaded with Unix. And they did their experiments for the original backroad search engine. And they would just do this using normal GCC and Python, and they would crunch the numbers and come up with what would become Google. Google would always use open source software as its fundament. We would find the cheapest hardware possible. How many of you are hardware people? You like computer hardware? Just raise your hand. So can you tell me what's wrong with this kind of server?
It's not very space efficient.
It's not very spacious. Actually, it's very spacious. We cram a lot of crap in there. Heat. Yes, that's a side effect of that. So we had a set of these particular servers. The heat rose as heat does. It's an engineering building. We all know that heat rises, right? In a gravity-oriented environment. So the heat would rise, and we had these hard drives that would desolder at a low temperature, and so the solder would drip. You don't want solder to drip if you're not a hardware person. And so the solder would desolder and drip down into the motherboard below. So that was bad. So heat was a problem, yes. What else? Anyone else want to conjecture what was wrong with this kind of server design? No? Yeah? You're mouthing something. They're not covered. Actually, the not covered was nice because we could get a lot of airflow. Yeah, so that was okay. So like the stuff in the back, you can kind of see it there in the middle. You can see like this fabric of fans that we had wired up, to pull air through it. Because that was one of the good things about it. There wasn't a lot in the way to get air in. But these cables on the side, when you slide one of these racks out to do some maintenance, replace a hard drive or whatever, it would actually snap the network cards off. So that was bad. There was a lot of problems with these, but they did allow us to cram lots of machines into a given structure, which made us very popular in data center that we were renting at the time. Then we would go on to make our own data centers. And again, what you're looking at are basically machines using commodity parts, the same parts that you were buying at home, just a lot more of them. And we only really started making our own motherboards sometime in the middle of the last decade. And then, running Linux, running compilers, running, a lot of the same tooling that you would do right now if you were going to be hosting something online. And we would use, back in the beginning, we only had thousands, but now we have about 4,000 or 5,000 libraries that we commonly use that come from the outside world that are written by people very much like yourselves. So we use open source everywhere. And that could be the end of my talk, but that would be kind of boring. So the question is, why do we do it? Right? So we've talked before, it's like, oh, it's this great resource. Isn't that exciting? But Google's a big company now. We could just write our own software, buy it, right? Adopt a whole not invented here sort of attitude and go from there. But you have to realize, as we were growing as a company, there were other companies that didn't like us that much, it turns out. And some of them still don't like us, Oracle. And, and the problem with that is that while we're a customer of a number of external technology providers, so are they. And so they would go to our common sources of parts and the rest, and they would say, listen, it's great that you want to sell us these hard drives, these chips, and the rest, but we notice you're also selling to Google. Maybe you shouldn't do that. Maybe we won't buy from you anymore. And so, at least in the realm of software, we could very easily say, well, that's really nice, but we're not going to be dependent upon the people who seem to dislike us for technology. And open source gives that to us in ways that really you don't have in the other realms of supply chain management, right? We also have the ability to sort of control our destiny. And what I mean by that is if we want to, so if you go and buy a license to, say, Oracle's database today, what they'll do is they'll say, okay, what are you running it on? And you say, well, I'm going to be running it on this server with this chip and this hard drive and this memory. And they'll be like, oh, that chip, that has hyperthreads, so we're going to charge you twice as much for every core you run it on. And how many cores does that chip have? And we're like, 6. Okay, 6, so 6 times that's 12. And how many chips are on the motherboard? You go, 2. Okay, so that's 24, so that's 24. You owe us $100,000. And it's like, whoa, I really only need this much of Oracle. I don't need that much of Oracle. And you end up having these really weird discussions. And on top of that, then they have the right to come and audit your hardware and see where you're running this. And they'll exercise that right, to make sure that you're not ripping them off. And the problem with all this is that, again, the people who don't have your best interests at heart, if you end up depending on them, you can be kind of in trouble. Because then they know exactly what's important to you. They know exactly how many machines you're deploying for a given service or whatever. So by taking away the incentivization for them to hurt us, we can make our own software more nimble. We can increase our velocity, and it's nice to take away some of the weapons that people can use against you. And then, honestly, so many of us just came out of the world of open source. Of course we're going to do it. And so we do. I could stop at just our healthy use of open source. Yes, we compile with the licenses. Yes, we do all this stuff. But, just using open source is really just the beginning. And there are plenty of companies that are happy stopping right there. You'll never see a single patch from them. But we have thousands of people patching every month. We've released, actually, this is an older slide. We've released over 4,000 projects. And I'd say probably 2,500 of them see active updates. And that's everything you might imagine, from parts of Android and parts of Chromium to, the full, Broadcom network fabric switch stuff that you use in Linux. There's a lot of stuff that we've released over the years, and it's something we're actually really pretty proud of. But then we also did some really, really large projects. So Android, it's funny, if you look at the history of desktop machines, that was coming, or was really already there for smartphones. In 2004, the smartphone market was nascent. It was very small. But it was largely dominated by Nokia's Symbian operating system. And they had, at the time, something like a 90% market share, 84% market share. And then you had some BlackBerry, and you had like 5 Windows phones that were being sold a year. And then, everyone knew the iPhone was coming, and that Apple had been thinking about it. And Andy Rubin at the time was going around with his Android team trying to get funding for their company. They were 5 people at the time. And their pitch was, listen, we want to write the last cell phone operating system. It's going to be based on Linux. They had come out of the Danger, the Sidekick thing team. I don't really describe that well. But it's the one that went snap and had like the keyboard and everything. And then they were going around basically asking for money and doing a startup around Android. And when we heard their pitch, we're like, we agree with you. We should do the last cell phone operating system. But why don't you do it here? We'll just buy you and incentivize you, and we'll hire a ton of people and get it done. And that's what we did. We hired hundreds of developers to work for Andy and Android. And then we launched that in 2008. And what we wanted is something that was more like the internet, that was more able to be on the internet than what was honestly going on in smartphones at the time. If you wanted to have, for instance, Google be part of a Symbian phone, we would end up having to cut a technology deal with Nokia and a deal with the carriers to allow their users to come to our website and use it. And this can sound really offensive or not a big deal at all, depending on your personal ethics and the rest, but we were like, it kind of stinks to put that kind of gateway in front of the internet, and shouldn't we be avoiding that? And so we wanted something that was like that in our cell phone operating system, and we wanted something that wasn't going to be a sneaky little patent stabbing you back thing. Like if you adopt it, well, it's free until we charge you. And so we released it under the patent granting Apache license when we did it. And that's Android. So this is a little older. We have more than 1 million devices activating every day. We've passed the billion device mark a long time ago. And that's just the ones that work with Google. There's a whole cottage industry of phones like the Amazon Fire and the Yandex phones and every small Chinese manufacturer in China shipping phones that don't ever talk to Google. So that's different than the 1 million plus devices every day and the billion or so that are already shipped. So the idea was that we could bring together a phone that everyone could use, anyone could ship, they wouldn't have to talk to us. And we were largely successful at this. Of course, there's another operating system out there called iOS. I don't know if you've heard of it. It's from a small company in Cupertino. And it's moderately popular. You've got the one with the ears. Yeah. Sorry, I don't mean to tease. But you know, the way we approach the operating system is very, very different. And sometimes it aligns with people's feelings on operating systems, and sometimes it doesn't. But the thing is, I can tell you the world would be a much worse place if we didn't have 2 extremely strong players in this market. And 3 if you count Windows Phone, but nobody really does. So, does anyone have a Windows Phone? I mean, I've seen a couple. Yeah, so there you go. Did they give it to you for free? Wow. It's the Lumia, I'm guessing. Yeah. Yeah, those are fantastic cameras on those. You know? No, it's true. They do. Come on, you know. I mean, we can be nice, you know. I didn't bring any phones. I'm sorry. But you know, it's important that we have strong players, even the smaller players. Not that you're smaller, but your phone. And it's just thinner. It's actually pretty big. It's important that we have lots of players playing this game, because otherwise, honestly, what ends up happening is when you want to ship an application, they say, well, that's nice and all, but... And if you can say, well, listen, I'm already shipping on Android and I'm shipping tens of thousands of units, they go, fine, you know. And it really makes it a fairer marketplace for proprietary applications and a better one for open source and free software. So it's really pretty important. Similarly, it's been a while now. Google used to be one of the biggest patchers into Firefox, which is a great browser. We wanted to take the browser in a very specific direction around sandboxing of the individual tabs so they couldn't bring down the whole thing. We wanted to patch in lots of JavaScript performance improvements. And the thing is, both of these things, they're not small patches. They're not just small feature updates or DOM updates, the document object model updates. They're really big. They touch every part of the browser. And so as we were preparing these patches for Firefox, they're like, you should know, we're not going to take this. We don't need that patch like that. And we're like, but we really want to give it to you. And so instead, we ended up shipping our own browser called Chrome. And Chrome's licensing is very interesting. Again, I know maybe I'm saying interesting to me because I like licenses, but we picked the licensing for Chrome very, very specifically. So that the work we do on Chrome would be able to be consumed by Firefox, by Safari via WebKit, and even by Microsoft if they wanted to, because it's under the BSD license, they can adopt it. And then for something like this, you know, we just really wanted to express ourselves. We wanted to express our ideas around sandboxing. We wanted to bring a desktop-like functionality to the web. And what we meant by that was you would have immediate and fast JavaScript performance. We were implementing some aspects of HTML5 that nobody really wanted to do before, like worker pools and local storage, and integration with everything from orientation sensors to the GPS and the rest. So you could even have some sort of mobile experience that made sense via your browser. And then we went a little further than that. We implemented hardware that just implemented Chromium with Chromium OS. And you notice I'm saying Chromium versus Chrome. Chrome is the closed proprietary implementation that uses Chromium, the code base, as the browser and as the fun. There's some things inside Chrome that are not open source, like the malware detection that round trips to the API that we have. And there's actually, that API is open for you to use for anything. And even Mozilla uses it too. But yeah, so Chrome has the proprietary bits, like because we had to cut a deal with Adobe to securely implement Flash, because otherwise it's just sort of a security nightmare. And I mean a security challenge. And and the same is true with PDF. You know, it was very hard to encapsulate PDF inside the sandbox model if you use the external NSAPI version of the PDF renderers. So Chrome was able to cut those deals and have the proprietary software sitting inside that. And you don't see that in Chromium. And then you see people who you would consider our competitors even implementing their own browsers using Chromium. And that's actually fine. We're totally okay with that. And the reason you know we're okay with that is because we released it under a real open source license. And this is a very important point. You'll see people talk about open technologies and open source, but if you can't actually compete with them using their own code, it's not open source. I can guarantee you that. So that's like a great litmus test. You know, like all those people shipping phones based on Android, it's totally okay. And what you realize is that Android, the Android open source project, is really open source because Yandex and Baidu and Amazon are all shipping things based on it. And they don't even ask us. They don't talk to us. They don't want to talk to us. They're like, nah, you're Google. And they just replace all the Google services with theirs and they ship it. And that's a testament to open source software being what it is. And then we end up competing with ourselves, really, to continue to make a nice operating system. And that serves all of you well. In the world of codecs, we have sort of a funny situation. So I don't know if you're familiar with H.264 or these video codecs that are omnipresent in your life. So for instance, I understand they're recording this today. I don't see, is it from this camera here?
Yep.
So that camera, it might be a commercially licensed camera, but it's more likely it's using the non-commercial license for the codec. Because most people don't actually license the commercial codec as part of their installations like this. And what I mean by that is your H.264 encoder that's tied into that system, it's actually only licensed for personal use. And they don't define what personal means, by the way. But if you were to ask them, they'd probably tell you you owe them more money. So what we wanted to do is whenever you buy a cell phone, for instance, you're actually paying between $0.25 and 50 cents to some patent consortium for your codecs. And again, that's for personal use of the codecs. So whenever you take a video for your Snapchats, your Instagrams, or your Facebooks, or your Google Pluses, you're using that patent royalty costed codec. And they actually pay for it through the factory directly. So you actually never really know. There's no like line item in your phone bill that says codec costs, but it's about that much. And it actually is a drag on the system. So when you want to ship a phone that is rapidly getting cheaper and cheaper, that incremental cost of patents goes up and up and up, right? So we purchased a company called OnTick Technologies out of upstate New York, and they'd been working on a codec for some time. At the time it was VP8, but we iterated with them, and now it's VP9 and WebM. And what they are, they're just what we believe and what we think we've tested to show is just a very high quality codec. And we've released this under the BSD, but we also have a patent grant alongside it, so you know that if you use it, you're not going to be messed with. And when you see a video on YouTube that is presented via the HTML interface, it's actually using this codec, especially if you're using something like Chrome or Firefox, because Firefox, like us, is aligned to use this codec. And we actually just recently had an announcement where Microsoft and to a lesser degree Apple were agreeing to ship the codec in their operating systems. So we all need royalty-free codecs to sort of keep moving things forward. And honestly, hardware is getting a lot cheaper too. So if you want to serve people who don't want to spend $700 on a phone, even that's the unlock cost, but even after a carrier cost, multi-hundreds of dollars on a phone, you need to really look at where all of the costs are going. And so this is a great way of bringing down that cost. And also, for those of you who are more freedom-oriented, this is a very important thing. Now, since this was very much a machine learning-focused conference, I want to talk just a little bit about the Deep Dream release. We have a project internal to Google called Google Brain, and we've done some publications about this and done some blog posts about it. but we wanted to actually release something you could see the outcome of it was. So if you go and you Google for it, you can see github.com, Google Deep Dream is where you can download it. It's just an IPython notebook, and what we did is we used Caffe as the enabling technology for this open source release. And what we did is we took quite a large number of CPUs and GPUs, and we trained a bunch of neurons on a very large set of images, and literally millions of them. And we lit up probably thousands or more than tens of thousands of neurons, or neural networks that would respond to them. And so we found ones that lit up for the cat image and for girl and for boy and that sort of thing. And that was really neat. And we're like, well, what if we could just turn this around? And you could give it an image and say, I want it to light up the cat, the snail, the river, the Surratt neuron, the neural network, right? And so we came up with a way of basically, it doesn't, minor changes to the image until it fits the neural network. And then we released it as Deep Dream, again, under an open source license under Apache, which is, again, a patent granting license, so you can use this and see the technology. And this should foreshadow future releases in the deep learning space. And it's really fun, and that's where that first image came from, although the first image wasn't a great one. There's been some crazy spooky ones. Somebody took the Johnny Depp movie, Las Vegas, what is it? One of you must know what I'm talking about. Fear and Loathing Las Vegas, and they ran it through Deep Dream the whole way, and it's just like, I haven't felt this weird since high school. So, it's worth checking out if you're interested in CNNs and our deep learning frameworks like Brain, or just want to be kind of creeped out by what you can do with images. So, so we just keep on doing it. We keep on releasing things, and it's very much part of who we are and what we do. WebRTC, you might be familiar with. It's how we do things like Hangouts, and it's used by a lot of the online providers now for doing real-time communications, both video and audio. Omaha is something a lot of people don't know about, but it's super, super handy if you're distributing software. It's a great way of doing software updates online, and it does this really brilliant compression, so you can update without having to use too much bandwidth. You don't have to re-download the whole thing. You can just update what's changed. Gennady is for systems management. We also have a bunch of system management stuff. I should really list Kubernetes. How many of you are familiar with Kubernetes? You must be a systems nerd, so yeah. It's a great way of managing really large clusters of machines, and it's inspired by our work for our own data centers on a system called Borg. But we've done a lot of things that actually haven't been all that popular either. Like white spaces. If you want to ship data over the UHF channels that are unused in the United States, especially, I don't really know the situation in Europe, so forgive me. But in the United States, especially with our topography being as varied as it is, from the plains to the mountains to the coasts, and also the way that people transmit on the ultra-high frequencies, you have to be very specific what frequencies you're allowed to use at which power. And so we ended up maintaining the database, the geographic database that would inform those radios. And that's currently in testing in sort of rural areas in the United States. And it's very, very fast. The networking is super fast. But it couldn't be done without having these sorts of centralized databases. And so one of the first things you do when you turn on a white space radio is it comes up just enough so it can reach these databases, which we maintain with the FCC. And then it's able to do the data transmission it's supposed to do. Another thing that we saw some interesting popularity because of was MLab. So if you go to Measurement Lab online, you can download a client, and it will measure specifically how good your connection is, not just to the head end of your cable provider, which is what most speed tests are doing, but also, what would happen if you started torrenting? What would happen if you started torrenting to a server that was much, much further away than just there on your local network, basically? And we were able to show, especially in the United States, the problems of local bandwidth providing and show actually how wonderful states like Denmark were compared to the United States. And we did a publication that showed how Netflix was being throttled by the various network providers so that they could then turn around and charge Netflix for the right to get to their users. And this led to the network neutrality legislation that came out late last year, early this year from the Obama administration. So these have really wide implications, maybe more in the United States and maybe more for Android users, but it was pretty important. I don't know, how many of you take the London Tube and use directions from Google or from anyone really on your phones? So whenever you're using that, you're actually using work that we pioneered, and then we took the specification, we said, listen, we don't want to own the specification, we don't want to charge you to use the specification, so we would release the specification for transit standards under an Apache-like regime, so that anyone, whether it's Microsoft or whomever, could then consume those routes and give you really good advice on how to get where you want to go. And again, it's one of those things where we could say that Google's size, Google's power, however you want to characterize it, we would say, listen, we really need this data. Here's a great standard, whether it was VIP for voting information or the various transit standards for buses and trains and the rest. And just by using it more, we're able to focus some real attention on them. And then we make sure people understand that we're not just improving it for us, but for the whole web. And that actually, it protects Google in a lot of ways too, because if more people are using these standards, the better off we all are as websites, as web search engines. So how's open source actually doing is a really good question. None of you asked it, but I put a question mark on it. When people are new to open source, they seem to be attracted first to things like games and to the web frameworks, the AngularJSs of the world and the rest. The Rubies. How many of you program little web things using any of these JavaScript frameworks or Ruby frameworks and that kind of thing? Yeah. So these are great sort of gateway drugs into open source. And we created a structure specifically targeted at people at your level in university called the Summer of Code. And I don't know if you want to do this, but what we do is we basically pair you up with open source software development projects like the Python Software Foundation or Angular or whomever. And we pay you over the summer to basically work on things with them. And it's really nice because you're exposed to the real problems that users have with these projects. You're exposed to the real bugs that these real projects have. So, because one of the failings of academia, and I say this as someone who used to be in school, one of the failings of academia is we can be very, and appropriately theory-based, we can be very targeted at, moving forward computer science. But the reality of many of the industrial jobs you might have after university is we often care about our users maybe a bit more than we should. And so by taking part in the Summer of Code, you can get exposed to user problems and the problems people have when they try to run their software in alternative environments, alternative chipsets, or whatever it might be. So if you want to do that, that's great. If you have young friends who are 13 to 18, we also have a program for them called Google Code-In, but I don't see many 13 to 18-year-olds here, so I won't waste your time there. So from a how's open source doing perspective, there's been a lot of talk lately about women and minority participation in open source. It's getting a little better, but it's reflective of computer science as a whole. What's funny is actually in Malaysia and some of the other Muslim nations, we actually see more participation of women than men in computer science. But in the Western world and in Europe, I'd like to see more of it. But so we try to target it with certain funding targeting. But it's coming along slowly, especially in open source. So there you go. That's the long and short of it. And I'm happy to take questions until literally I fall over. So if you have any questions about Google, about open source, or about what we're doing and things like, that you might care about, I'm happy to take questions. I have no idea how much time I've taken up so far. I sometimes talk way too fast. I have 20 minutes. Oh my God, I talk way too fast. I apologize. But yeah, I'm happy to take questions and yammer for hours and hours. So is there any questions that you have about anything? Yeah.
Does Google have any sort of open hardware projects? So you mainly be talking about software, but what about?
So does Google have any open hardware projects? So there's two answers to that. One is no, but that's a lie. So there's two positive answers to that. The first is actual hardware like Gerber files and that sort of thing. We've done that from time to time. We don't do it a lot. We've released technical specifications for things like power handling systems and some of the tricks we do inside our data centers for bringing down the power cost of a given data center. But we haven't released a lot of hardware specifications and chipsets and that sort of thing. We have released hardware implementations of the codecs that we've done, and then there's a lot of like little hobby things that Googlers have done that we've released, but they're hard to find, and we've never really put a lot of effort into organizing that. So I mean, you've only really seen it around the codec hardware specs. The other side of this is we do put a lot of effort into bringing hardware compatibility to Linux that people never really know about. We really wanted to use, for instance, Broadcom network fabric chips. This was back in 2006. And Broadcom simply didn't have the Linux drivers, and they weren't going to write them. They only really wanted to write them for, big router manufacturers. And we're like, no, we want to use Linux on top of them. And they're like, that's weird, you're strange, get away from us. But we cut a deal where we would get the specifications from them, and we would write the Linux kernel drivers for these fairly, at the time, esoteric chips. And we've done that a lot, actually. So as Android's developed, we've written and released hardware drivers for a vast number of devices, because we really don't want to ship user space drivers for things, and sometimes we have to because the manufacturers are not interested in an open source implementation of their compass calibration routine or the video driver or whatever it might be. But sometimes they're willing to let us release it for them or let us write it for them. And so we'll do that so that we can have more of the operating system exposed in the open source way. So that's really where you see us in hardware. And then we do some funding on the side of little projects here and there, but it's not really that significant. So. Yes?
In terms of us over here, possibly...
You three.
Oh, yeah, sure. No, everyone here. So working on these maybe small projects on GitHub or something.
Sure.
You might be working on in a group, maybe hope a few thousand people around the world might look at.
Sure.
Star color and stuff.
Stars, very important.
Yeah, great.
Yeah.
What sort of open source licenses do you think we should be looking at?
So the question is, are there open source licenses that lend themselves better to drawing a community to your project? So I have a fairly unpopular view of this, and it's that the open source license matters not at all. And what I mean by that is you should have one, right? Just having an open source license on GitHub puts you in the 25% case. Because right now, if you look at GitHub, and I've looked at all of GitHub, not personally, I have scripts that do this. If you look at the top 30-day active projects on GitHub, which number about 7.6 million right now, that are open source, it is 25% of GitHub's projects. And so the first thing I would say is just using an open source license puts you ahead of the crowd, because that means people can actually legitimately use your software and download it and have fun with it, and they may even give you a pull request to improve it. There are a lot of people who will say, oh, you should always use GPL. It'll force people to give you patches. They'll say, you should use Apache because then you'll get more people using it. I've seen people use any license, right? And what it came down to was how solicitous they were to new users and new developers, and frankly, how inherently popular their software was. Most JavaScript frameworks, you'll notice, which are hugely popular on GitHub, are under extremely permissive licenses like the BSD and MIT license. And so what I usually tell people at Google when we're releasing software is, what are the developers who are like your project, who write things like your project, what are they using? So when we release an AngularJS, it's under a BSD license. It's not under an Apache license, which is my favorite, because I think it's the best one, because of the patent granting language. But everyone in JavaScript land, they use BSD, or they use MIT, depending on which coast they're from in the United States. But they're broadly compatible, so it doesn't matter. But if you went in there and said, hey, everybody, this is my, Eclipse public license JavaScript framework, they're going to be like, just get out. Don't want to talk to you. So it really comes down to, what does your audience want? And what's your project, you mind if I ask?
Just generally.
Yours generally. You're not actually doing any work.
Oh, yeah.
Yeah. No, but seriously, people get really worked up in this because there are issues of passion and kind of religion, but not really, around these licenses. But I've always been a practically oriented person, both for Google and myself. I just want people to use my software. And so I've always favored permissive licenses because I just want it to bloom and to blossom, you know. In the case of something like Android, you know, using a copyleft license for the parts of Android that were above the kernel, it was never going to happen because the carriers, they just don't grok what it means to be compliant with the GPL. And we had written a lot of scripts in Android that basically made compliance with the Apache licenses they're in and the BSD and the MIT, the few that were in there, very, very easy. It built the compliance architecture for them. So if you go to your phone, for instance, those of you who have Android phones, actually you see this on the Windows phone, the one Windows phone, and the couple of Android phones here. If you go to your About Legal section in your phone settings, you'll find out very, very quickly a page that says open source licenses. And that's something that we started with Android, and it's on Android, it's like 300 pages long of licenses that we're obligated to show you, but we're also proud to show you. And that's all actually part of the way you build Android. You have to actually really want to screw that up with Android. So I don't know why I'm going off on this tangent, just because I like it. So I can tell a fun story since I started talking about Android. The very first Android phone we shipped, the G1, I don't know if you remember this phone, it had a little snappy Yeti keyboard thing. Snap, snap. When we were first deploying it internally with the compliance information was so big that it actually blew past the size of the storage of the phone. And so that wasn't going to work. And so I was like, well, wait a second. Text compresses really well. It's just compressing. So we compressed it, and that was great. But then it crashed the web view that was using to render the text. And they're like, oh, yeah, we have that bug. And, you know, and so they fixed the bug, and then it showed it. It took a little while to load, but it worked. And, you know, this was like the dinosaur days of mobile phone processors. So, but it's always been really important to us to get that right. So, yeah. Yes?
So you talked a bit about Deep Dream, but can you talk a bit more about Google's policy regarding open source and AI and slash machine learning?
Sure. So to date, the only thing we've really open sourced around deep learning has been the Deep Dream stuff. We have more stuff coming.
DQ.
DQ, yeah. Well, and there's patches and things like Cafe and Cafe 2. I mean, the thing is, we have a lot of employees. And so, you know, I approve a patch and then it just drops out of the back of my head. It's like a leaky bucket back there. So we do a lot of things that benefit people who are in this space. But big splashy releases, probably the biggest thing we've done has been like Deep Dream and stuff. But more is coming, and it's very exciting to us. We've done a lot of papers, actually. Jeff Dean has published a fair number of papers on the topic, and a number of our other researchers as well. So.
And how about data sets? Because you're a researcher.
Yes. Yeah, so here's the thing. So ImageNet is a very popular data set. That is for research use only, and we've clarified with them exactly what that means. And they were comfortable with us using it for things like image training and the rest. But yeah, no, the lack of data sets that are usable in a commercial context especially is very disturbing. So we've talked about, for instance, we've released the Ngram database from long ago, and that was released under a Creative Commons license it was not Creative Commons by attribution, I think. And even that might have been too heavy-handed from a requirement standpoint. But it's actually really hard to find these data sets. So we have a data set of utterances for speech that we've been trying to figure out how to release for a while, and I should really check into that. But yeah, there's a lot of data sets out there that need to be released, and that would be really cool. And I think that we'll have a release of something relevant in about 2 months, so you'll want to look for that, but I don't like pre-announcing stuff. But yeah, the data sets problem is a huge one because collecting really valid data sets for machine learning is really hard. And we saw this actually when we did our first initial releases of the Tesseract OCR technology. We had like this corpus from the book scanning process that we were using against it, but because of the status of the lawsuit around book scanning, we couldn't really distribute that either, right? Because people would see that as a copyright violation, well beyond fair use that we were trying to articulate around the book scanning project. So, you have these problems with the law, right? And then, I'm sure you've seen these. We had a paper about this as well, where you try to describe what's going on in a scene, and you're like, okay, so it's ridiculous to think it, but you'll actually have people complain if you recognize something of theirs in a scene, right? We saw this actually to a lesser degree with Street View, where people really didn't want their pictures on Street View, which we respected and we would pull as soon as we knew. And then we started blurring the faces. You might remember this. And we were blurring like statues, like on Trafalgar Square, and like the statue of Jesus, some statue of Jesus, I think in Brazil, like, you know, but face was all mushed out, you know, and a horse's butt for some reason. But anyway, I was like, wow, we're matching horse butts now. That's really something. But yeah, but getting those source images out can often be fraught. And I'm not going to lie to you, sometimes we start to do these things, and then there's this onslaught of concern, and then we're like, ugh, you know. You might remember America Online. This was like 10 years ago. They released a set of 10 million searches that people had done via America Online. We had considered doing something like that, and we decided against it, because we've always considered searches as being very personal, even when they were anonymized. But anyways, AOL, they weren't as worried. They released this, and the New York Times basically walked the graph, and they found this nice older lady. Her husband had died, and her dog was sick. Her dog died, and then she was lonely, and then she joined like an elderly singles thing, mailing list, and then she went on a date, and they found her and they, hey, is this you? And she's like, my God, how do you know all this? I mean, this is my dog died. This is really sad, and I don't want to share this with the world. And they're like, well, it was all anonymized, but she had searched for enough things. It was very easy to find her. And one of the things we found with that kind of search data is it's actually super easy to zero in on who people are, just through their search text, not even through looking at IP addresses or all the rest. So it's something, as a search engine, we're really, really concerned about this. So when we've looked at those kinds of data sets, which you would think would be fine, they're really not. And so we end up being a little more conservative, right, than an academic institution might be. You know, so. Anyway, that's a lot of yammering about data, but we actually have to really care about this. And we actually genuinely care, because we don't want to alienate some nice old lady who just wants to go on a date because her dog died, you know. So, yeah. Anyway, like, you might remember the Netflix movie challenge thing, where people were analyzing Netflix movie data to find out why people like Napoleon Dynamite at all, because it's a terrible movie. Sorry, that was one aspect of the challenge. But it is a terrible movie, just for the record. I couldn't make it through it all. People are like, oh, you should watch the whole thing. And I'm like, no. But maybe you have a lot more time. Anyway, they were going to do a second one, but they determined that you could simply, through the pattern of somebody's watching of movies, figure out who people were and zero in on them too. So they ended up canceling their second iteration of that out of fear of alienating their users and violating their privacy. So this happens actually way more than people think, because if it's a human-generated data set, or if it's about things that are truly human, it can become really weird really fast. So, yeah. Any other questions about Google, about open source? Okay. Wow. You want to get me in trouble, huh? So the question is, why did we sell Motorola? I'm still wondering why we bought it. So not for good or for bad. It's just, I'm not in the deal flow at Google. They bring us in after they decide to buy things to make sure they're not violating open source licenses. And sometimes I look at them and I'm like, we're buying what? And Motorola is a big company, right? It was our first sort of mega acquisition after DoubleClick. So DoubleClick was a big acquisition for us. Motorola was much bigger, right? And the reality is we needed Motorola's patent portfolio to help defend ourselves against other patent holders in the United States and elsewhere. So I know we derive value from owning Motorola, right? And if you look at like the pieces we sold off and how we sold them off and the sort of estimated value of the patent portfolio, it all kind of evens out. Right, but I couldn't tell you why, past that, the spiritual reasoning behind purchasing or divesting any of the things we've done. I mean, Android was easy, right? And at the time when we bought Android, I was like, we're buying a cell phone company? What? But, I got to know them and they were really cool. And I was like, oh, we probably bought them because they're so cool, But yeah, we've bought a company every 2 weeks on average for the last 5 or 6 years. So, Motorola is just a much bigger version of that, to my mind, So I don't really have a good answer for you. Sorry. Was there any other questions? We could probably fit one more in.
We can go to coffee and take the question.
Oh, go to coffee. Do we have to go back to the other building?
Yeah.
Okay, there you go. So, okay.
Okay,
So,
let's
yeah.
time for
I hope that was okay. I hope that was a good question.